Yesterday, for those of you that tuned in, we had a big day for autonomy, talking about autonomy and adoption for drone-in-the-box technologies and also AI for advanced inspections. We did a drone-in-the-box deep dive with Kurt from Hexatronics, which was tremendous. And then Eric finished up with a fabulous interview with Captain Miriam Fox of Chula Vista PD and their drone as a first responder program. So that was our first kind of public safety first responder session. That's going to segue really nicely into our session this morning, which is multimodal robotics for public safety. So we have an excellent panel of different modes, and we have air, ground, and sea, which is a focal point of us here at RMUS. And we are excited to have these gentlemen. Later today, we will be running into a couple of sessions. We also have 3 today. We'll be talking about advanced industrial inspections at 2 o'clock. We'll have some of the most innovative manufacturers of hardware and sensors that you're going to see. So stick around for that at 2. And then at 3 o'clock, we're going to do a deep dive on AI inspections and the next generation of inspections with Ontario Power Generation, which is powered by Spot. So that's something Matt's certainly had, and they are big users of Deep Trekker for Carter, and I think they probably have a couple of Autels too, John. So that'll be very apropos for all our speakers. So that's the rest of it. I'll go through that at the end. But for now, we have assembled another all-star panel. We have Drone Jesus, we have Sensei Knights, we have Admiral Carter, we have a who's who of heavy hitters in the first responder robotic space. And so we are going to get into updates and adoption in first response robotics with these 3 fine gentlemen. So let's introduce them. I'm Kevin Totter, by the way, of RMUS, not as important as any of these fine gentlemen. So let's start with you, top right. I would like to introduce the legend himself from Autel Robotics, Jon McBride. Jon, introduce yourself and a little bit about Autel in first response, please.
Sure, Autel Robotics. I've been here just coming up on 2 years, Kevin. So it doesn't seem like it's been that long, but probably the biggest one that really fascinated me, of course, was the Dragonfish. We've used a lot of smaller UAS and drones and things like that. I've got a Max here that's coming up pretty soon for release, and getting out there to the field and doing some good work in the public safety area. But we've been really focusing, at least I've been really focusing on Dragonfish, the possibilities of what that aircraft does, the long flight time, the great visuals and sensors that you get from it. So, but we got a lot of fun stuff coming as far as Autel is concerned, and happy to be here on the show. Really appreciate it.
Excellent. And for those of you that might not be aware, Jon and I hosted the first annual RMUS Tech Week, so he was there, and so we miss him, and it's good to have him back with us. So secondly, we're gonna go clockwise, so not in alphabetical order or anything like that. From Deep Trekker, he has flown in from his various international travels spanning the globe for promoting ROVs from one of our favorite, actually Canadian companies up the road here in Kitchener, Deep Trekker. Please welcome Carter Sinclair. Carter, please give us an intro to yourself and Deep Trekker.
Thanks, Kevin. Like Kevin mentioned, my name is Carter Sinclair, and I'm the account executive here at Deep Trekker, who looks after global public safety, military, and defense. So Deep Trekker makes underwater ROVs, and if you're not familiar with what an ROV is, the best way to describe it is it's a drone for underwater. Deep Trekker's in 110 countries. We're in 10 plus industries doing everything from aquaculture and fish farming to military and defense. Now, defense and public safety is a huge domain in of itself, but there's a huge amount of civil infrastructure and objects that need to be imaged underwater, which can be very hazardous to divers. Deep Trekker ROVs are a remote solution that can dive through the water up to 300 meters or 1,000 feet in depth. to do everything from body and evidence recovery, crime scene imaging, vehicle recoveries, explosive ordnance disposal, so on and so forth. So I've been with Deep Trekker now for over 4 years and working with teams from across Canada, the United States, and the rest of the world on how to make their underwater or subsea operations safer and more efficient for those involved. Look forward to talking a little bit more. Thanks.
Excellent. All right. Thank you very much. And it's interesting, Carter. We were talking a lot about digital twins and data with Key AI, among others, and introducing this into asset management and things like that. And to me, one of the most exciting spaces is, Key AI. I think they just were awarded a Navy project, and that is going to be specifically for doing sort of underground scanning, or sorry, underwater scanning. And so integrating sonar into some of these asset management sonar data is a really exciting thing of looking forward at. So we're looking forward to that. I said exciting
Absolutely.
an awful lot there. But anyway, speaking of exciting, I'll introduce our third and final panelist from Boston Dynamics. You might have seen Spot Robot once or twice in some kind of media. You've probably seen Matt being interviewed by Barbara Walters, or actually she just passed away, God rest her soul, but other journalists of similar august stature. So he has joined us today, and we're very excited about that. Matt Knights from Boston Dynamics. So Matt, please introduce yourself and BD.
Sure. Yeah, my name's Matthew Knights. I'm the director of sales for Boston Dynamics. Been here about 3.5 years. Spent a bunch of time at FLIR Systems before that. Was in the U.S. Marine Corps. So this mission's sort of near and dear to my heart on a personal level. And then from Boston Dynamics side, most people know us from the famous YouTube videos. And we've sort of spread out into a wide range of industries, from manufacturing to construction to R&D. But I think what people are often surprised to find out is how many actual real world deployments there have been with Spot, specifically in the public safety arena. And happy to share a little bit more about that today. So thanks for having me.
Fabulous. All right. So thank you very much, gentlemen, once again. So let's get right into this. So John, I'm gonna start with you. A little bit more of a general question. So think back to the caveman days of UAVs back in 2014, 2015, when we had.
You gotta go farther. But yeah.
I'm not talking about like the amoeba days, anyways. So talk back to the first instances of unmanned systems in public safety, aerial systems at least. So talk about that. Give us a little context, and then kind of contrast that to how different it is today.
Well, at the very, very beginning, and you can go up just a few couple years before that. I mean, you're talking like 2011, 2012, and the breakout of what everybody knows is the Phantom series. The breakout of the Phantom series really did change both cost for the public safety guys, not necessarily Phantom 1, but Phantom 2, 3, 4. We just look at those as being awesome aircraft that were not very expensive to try to get to for other offerings at the time. Again, I do kind of give some props to DJI, because they did really try to, not try to push this, but they made products that public safety absolutely found to be very essential into doing the work that they're doing. As we progressed, we literally just had a simple drone with a camera. Even Autel at the time made the initial X-Star. Was it chose for a lot of the public safety platforms? Not necessarily, but it was just a drone with a camera. And then as things evolved, got a little bit better with the sensors, these kind of started to focus a little bit. So this transition really happened when I think the Inspire came out. So when the Inspire came online with a dual payload, you have an aircraft that could be held in an area, and a camera pointing around with a payload operator looking around to find a subject or see something or overwatch an area. And that idea, that concept of having an operator to fly the aircraft, an operator to run the payload, plus we had the XT, the XT2, other thermal cameras, now pushing into more capability of the tech, and again, sensors to do things. As we moved on, the initial first adopters, they really weren't dealing with FAA yet. We weren't dealing with major SOPs, and that, as we've moved forward and progressed, has now become a thing. So 107s, COAs, even up in Canada, different types of regulation that has now kind of adopted over to follow the rules, follow the stuff, and now we're seeing a lot of, again, compliance that has to be done. So just on the regulatory side, we've seen a lot of changes. On the technical side, we've seen a lot of changes, and it's become fairly easy now to kind of copy. But there's still a lot of things that we have to be careful on, because an agency in where I'm at in Utah versus an agency in New York are going to have different rules and different things that they have to kind of abide locally, and kind of have to watch out, again, what aircraft they're wanting to purchase or buy to be able to do those types of missions. But yesterday we had done an Autel webinar, kind of focused a little bit on this as well, this question. And I think, again, the big thing that most agencies get caught up on is always the equipment. What should we buy? What should we buy? What should we buy? What should we buy? And they spend 90% of their time trying to figure out, how long does it fly? Does it have a thermal camera? Does it have this? Does it have that? And some of these are brand new agencies, never even flown drones before. And they haven't done the foundational things, like I said, the regulatory side, try to figure out their SOPs. If they're going to have a dedicated officer to do something, whether they are doing an ROV or using the spot or flying the drone, do they have a truck or trailer to bring out there to deploy these on certain missions? Do they have training always done, retraining done? These are all things that are 90% of the time you should take, and then figure out the 10% of budgets for hardware and how to implement them into your SOPs. And so it's been really neat to see that kind of evolve over time, not just with the hardware and the capabilities of the hardware, but also how the public safety guys are addressing a lot of the questions that come up with the regulation side, and creating, again, rules adoption, and getting the command staff to really understand, like, we absolutely have to have this tool. Just as important as a flashlight going into a building, I have to have the drone go first, and it's really neat to see that evolving.
Yeah, and it's a great point, and we'll talk about regulatory and different issues in a second. But one of the things that with aerial adoption was there was a clear pathway. We're kind of replacing a lot of the stuff we might use helicopters or fixed wing aircraft for as well. So that was a transition. So Matt, I'm going to kind of throw it over to you. You obviously don't have the same regulatory issues. But for your experience, do you see this as Spot is creating something entirely new, or Spot is kind of replacing maybe tracked robots or something that they're already using, or is it a mix of both? So talk to me about how you've seen Spot adopted over the relatively short time that it's been available for public safety.
Sure. Yeah. So I can speak a little bit to some of the early field testing and how folks, police officers that were using robotics, thought about deployment, and some of the things we learned along the way. But I think it's iterative in reality. It is giving more capability to the officers in the field versus a traditional wheeled or a tracked robot. And one of our first tests with a team locally, they were driving the robot, and we had a suspicious package in the distance, and they started driving in this sort of roundabout way. And we asked why, and they said, well, there's a curb there, so we're going to try to walk up and over on this ramp. And we were like, no. The whole point of this is you can just walk it towards, it'll step up and over that curb. And even that mindset shift was surprising to them. And then as you get into more sort of interior scenarios, the idea of walking up a set of stairs, so it was really all around improved mobility, and then getting people comfortable. So getting up a set of stairs with a traditional robot is, a feat of accomplishment, and can take 10 to 15 minutes in some cases. And it definitely takes a trained operator. I think the difference And the total mind shift with Spot is really all you're doing is taking a joystick and moving it forward, and the robot's figuring out where to put its feet. And then from there, once we added the arm, now you can open up doors. So you can get further along throughout a building. Um, and really, one of our sort of power users, I guess, always refers to Spot as having the holy trinity of robotics. It can go up and down stairs, it can open doors, and it can get up when it falls over. Like those are the three things that people have really struggled with. And that's sort of the area where we think we can make that iterative impact and improvement over the tools that they're using today.
Mm-hmm. Yeah, and I will say I think back to literally probably the second day that we had our spot. Probably was one of the first ones. It was very early on, and the second day we had it up here, we took it to Festi, which is the Toronto Pearson Airport training ground, and your example was bang on. We had a bunch of the security people, and they said, "Hey, can it get on the bus?" And I'm like, "Yeah, I'm pretty sure it can." And I just took it on the bus, didn't think anything of it, barely had any time on the robot, and they were all blown away. And I didn't understand what the fuss was. It's like I just pushed the joystick forward, and they said, "Look, we have these iCore robots on tracks, and it can get on the bus, but it would take someone who knows what they're doing, like you said, legitimately 15 minutes just to get on the bus, right? And you just kind of put that thing up, and you don't even know what you're doing, right?" And so it kind of talks about what Jon says is that has a big adjustment in the actual tactics based on some of the things that you can do. And again, the ability to open doors is another one if you can actually do breaching. So quite fascinating.
For sure. And I think one of the big things that we have found is the autonomy that's built in, both in mobility and for manipulation, is a total mind shift. If you want to go open a door, again, with a traditional robot, you're moving each individual joint of that arm, and then you're manually operating. Whereas with Spot, you're really saying, here's the handle, hinges on the left, and then the autonomy kicks in, or picking up an object and dragging an object. You're just pointing and touching a touch screen to make that happen. And that, again, those are the things that shock operators when they sort of have experienced that struggle with having to manually be really precise in the movements. And then they see, a chance to pick up the controller, and within 30 seconds, they've picked an object off the ground or walked up a set of stairs or opened a door. They almost don't believe it until they really did it themselves.
Right.
And then you spend 10 minutes of them saying, "Hey, you try this, and you're opening the same door over and over, because in a sense they can't quite believe it's real.
Yeah, it rolls back around to just time. How much time, I mean, it's all about time. Even the drone is about time, waiting for a helicopter to come and deploy. That's time. Waiting for somebody to, get something out of the truck and assemble it and put it all together. That's time. The training that it takes to really manage, moving a track, time. I mean, it's all about time. And if you can save time, you can save people much faster. You can make decisions much quicker when there's not so much difficulty in just the general operation of anything, So it's really cool. Yeah.
Great point. So Carter, you guys are a little different perspective. So if you look at it, Jon, they're doing search and rescue for live people. They're involved in emergency response. Matt, they're helping SWAT teams do breaching. They're getting in and exploring fires. You guys kind of come in after, right? And so
Yeah.
I think from what I recall, you almost started in aquaculture, and public safety was, I don't want to say it was a surprise. I don't know if that's necessarily fair, but it seems like it's your fastest growing. So talk to me about how you guys deal with public safety and what's really driving the adoption of the technology there.
Yeah, absolutely. I think there's a huge amount of parallels to what Matthew was just talking about, and taking a concept, a tool that's existed for years, and really revolutionizing that user experience and the effectiveness of those existing tools. ROVs have been around, I think, since the 60s or 70s. They've been around for a long time, but they were expensive, they were heavy, they were unattainable for most departments, most organizations. And Deep Trekker was founded around the time aerial drones were really just taking off in 2010. It was becoming more mainstream. Now, ROVs up to this point had been extremely complicated and very unattainable for most organizations. And if you had one, you spent more time fixing it than running it. It was not a great user experience. We wanted to really capture what was going on in that aerial space and how these organizations were changing. And we were the first ROV to put a battery on board. And rather than having multiple joysticks and a big control console, we wanted to have a handheld controller, something that you could put your hands on and learn in just a couple of minutes. With that lower cost, that portability, and that ease of use, underwater ROVs, underwater drones really started taking off at that point and changing how things work. And exactly like you mentioned, Kevin, it really started off. Our first units were sold to a fish farm out in Norway. Now, Deep Trekker was really founded from the recreational side back in 2010. Hey, we can take this big work class ROV, shrink it down to something the size of a basketball, and people can go explore shipwrecks with it. They can inspect the hulls of their boat. And all of a sudden, when we launched the Deep Trekker in 2010, we had all these different organizations, everything from aquaculture, oil and gas, hydroelectric, OPG, police and first responders, thinking of different ways they could utilize it into their current workflows, make things more effective. But in the underwater space, the number one thing is safety. When you're doing a body recovery, and like you mentioned, we're not usually coming in the rescue phase. We're sadly being involved when there's been a boating accident, a drowning, a suicide, and there's somebody's family member in the water who they're hoping to bring home. That's been traditionally done exclusively by divers and the tools they are using on the surface, like side scan sonar. But at the end of the day, it's a diver splashing in the water to bring that person home. And if you've ever spent time in many of the waterways in Canada, throughout the States, it's usually very low visibility, very high current. And a lot of those divers, they're going in there blind up to depths to 100 feet and quite literally feeling around, hoping they find somebody without having a pre-dive or situational awareness. It's also time consuming. Most teams are operating with a diver in the water, a support diver on the surface, and a 90% diver. So for one diver in the water, you're having three people suited up and ready to go in, going into these hazardous environments with very little to zero situational awareness. Using the Deep Trekker ROV, teams started deploying that ROV first, getting situational awareness, figuring out what was down there, latching onto the target or something nearby. So now we have a dive guide through our tether system going right on top of that target. So when a diver got in the water, that operation was already inherently safer. Now, if you take a look at Deep Trekker today, what we're doing is we're, in the best case scenario, avoiding splashing a diver at all. Take Charlotte Fire Rescue, a customer we've been working with for a number of years. They started out with the Deep Trekker ROV, replacing one of their older legacy ROV systems they bought in the early 2000s that never quite lived up to their expectations. With the Deep Trekker Revolution, their goal was to use that to gain situational awareness while divers suited up, splash the diver, and do that recovery. Today, they're operating on a fully remote recovery basis whenever they can. And I think they conducted 16 fully remote recoveries last year. That's 16 times a diver never had to splash in the water and go in harm's way. On top of that, it's making things much faster because we can get that ROV deployed at just a minute or two, get it in the water, and complete that recovery. We recently conducted one in Stokes County in North Carolina. On this search, which would normally have been a full day, they were able to go out, run their side scan sonar patterns with their boat, splash the ROV, complete the recovery, and get back to that dock in under an hour. So it's really revolutionized the efficiency and the time that these families are looking for closure and made operations inherently safer for all those divers involved.
Yeah.
All
Fantastic.
about
So,
the time. All about
yeah,
the
so
time.
yeah, so John, I'm going to flip it to you. So that's the same thing, and I'll come back to you, Matt. Is safety and efficiency. So I think that's really the core promises of what it is we're doing, whether it's air, ground, or water. And we'll talk about how those integrate later. But John, I'm going to kind of flip it back to you. So with that in mind, like safety and efficiency. So one of the things that we're building into that is we're looking to broaden the scope of what we're doing. So whereas Spot gives new access to areas. Deep Trekker, again, it enhances existing and plus gives new ones. So you've got both quadcopters and you've got the fixed wing one now. So when we're talking about something like Overwatch, how does increasing that scale of what you can cover to provide Overwatch, how is that going to help departments be safer and reduce time and become more efficient?
Yeah. So again, knowing what drones can do, and we're talking the typical multi-rotor, when it gets deployed, holding, hovering, in order to hold this weight up is a lot of power that needs to be done just to keep it in a hover. And we've when we first start, well, when I first started, even before you were involved, Kevin, 5 minutes of hovering time was a long time. 5 minutes was a long time. And if we could get 5 minutes and 30 seconds out of a hover way back then, boy, we were excited. Now questions come in of like, how long does it hover, or how long can I fly it? And we're saying, 35 minutes. They're like, oh, is that it? I'm like, 35 minutes. That's an astounding amount of time for what it was 15 years ago. So Overwatch is really that. How much time can you stay in the air? How long can you hang out looking at whatever you're looking at? In most SOPs, or most kind of ways we overcome this, is to have two drones, one going up, one coming back, one going up, one coming back, so that we can always have Overwatch happening at any given time. Now, it's not always, like I said, you have to kind of be smart with the drone when I teach and train people, because if you only have one, you have to kind of be smart on when to deploy the Overwatch, meaning that like I'm not really interactive with what's going on, but I need to be and see visibility of important things within that 35 minutes of flight time. With the Dragonfish, you can just extend this time, and it is a fixed wing. We take off vertically, we fly around, but we can stay up there on our what we call the standard version, upwards of an hour and a half to 2 hours. And that's an extreme amount of time in comparison to 5 minutes, which I referred to, 30 minutes, which is about the traditional time that most drones hover and hold, to a sustainable hour and a half hanging around and watching up above. I always use the analogy when people ask me about, can a dragonfish do what this does? No. I mean, it's not made to hold and hover. Again, you come back to the whole idea of using a lot of battery to keep it still, rather than using the wings to keep it moving forward, and utilizing the aerodynamics, the physics to gain that flight time. And we don't want to mix the two, because it is really important to be able to look down through windows and kind of see what's going on for individual deployment, or individual thing inside the house and stuff. And then you do have an Overwatch aircraft, zinging around on top, just watching the whole situation. That Overwatch aircraft could be easily deployed way before any of the public safety guys get there. Any first responders get there. You can get there first and keep an eye on the whole situation. You can go ahead and catalog where your entrance points or egress points, where all of that's going to be, just kind of get a general idea. And then also at that time, with that an hour and a half to 2 hours of time, you can watch your units come in, command and control if needed. And that's really helpful. A second analogy I use is that Dragonfish is like a sniper rifle in the team. You have the ability to go very far. You have the ability to fly for a long time, which implies that the guys that are deploying don't need to move a lot. So where they choose to sit down and kind of stay still, because they have kind of an extended range and they have the ability to fly for a long time, they can fly a couple miles out and then a couple miles back without too much trouble. They don't need to move around during the close quarter missions. They don't have to do that. They don't have to figure out how to do that. So just like a sniper rifle, you just set your nest, you sit where you are, you watch what's going on, you make a decision as you need to. No need to move the whole unit around all the time because of the distance it can go, which is equivocally about 18 miles or 30 kilometers. And that always comes into question of like, well, if it flies that far, what are you guys doing about beyond visual line of sight? Well, there's a lot of things we can go down that road, but
Yeah.
the
Yeah.
fact that most of the deployments, I've got about 30 of them here in the United States, and most of the deployments right now for that Overwatch flight time are very close quarters. They're not but a block or two away for where the team's at. They're watching something that's happened just a couple, and they're just utilizing it for the flight time. They don't need to go 20 miles down the road. They're just close, and they're just there to watch it for the flight time. So.
Mm-hmm. Makes sense. So, so Matt, obviously, again, it's a little different. We have one, the safety is just better situational awareness over a broader perspective, but Spot can literally keep people out of harm's way, or allow for them to do different things. So maybe talk about some of the prime use cases that you've seen with the early adopters so far, where the Spot is actively keeping people safer out in the field.
Sure. Yeah, I mean, I think that's the main thing. And one of our core customers, who's probably deployed more than anyone else in the world, over 100 deployments in the last year, they have a general policy that they're not going to send an officer in until a robot has eyes on. So again, the majority of the time, what happens in a barricaded suspect or a high risk warrant scenario is the robot is going in to de-escalate a potentially stressful situation. So you can communicate, two-way communication with the suspect. You can see what is going on in the building, whether it's where the suspect is, or is the suspect armed, or is the suspect asleep, or whatever. So you have that situational awareness prior to sending an officer in. And what that really does is it makes it safer for the officer and safer for the suspect, because you're taking this really stressful situation and slowing it down. Again, getting back to the time side, sometimes you want a situation to slow once you're in, getting in quickly and then slowing a situation down so you can make good decisions. And that's one thing that we've definitely seen as probably the most common response or the most common application. Other applications that are sort of pretty common as well is EOD, so suspicious packages or unexploded ordnances. Time on target in this case is reducing the amount of time a person has to be near a suspicious package from a safety perspective, getting a situational understanding of what they're looking at, take the first look, potentially the first touch of that package, and sort of get an idea of what it is and determine whether or not you actually need to send an EOD tech in, or in unexploded ordnance scenarios. Oftentimes, they're just picking up an object and then moving it to a safer area, whether it's a box of sand or something like that. And then, the two other scenarios that we're seeing commonly that I'll hit on is hazmat response or CBRNE type response. So there's a chemical leak or a potential threat, and you can have a robot with a bunch of sensors go into a hot zone, understand what's in that environment as a team is getting suited up in a mock suit. So they, again, know what they're going into, know what level suit they need to be wearing, reducing the amount of time that they're in that hot zone. Again, just thinking about with oxygen levels and things like that. So those are sort of the main applications. And then just earlier this week, actually, and this became sort of public, FDNY responded to a collapsed garage scenario. And they've shared some commentary and some press on what the robot was able to do, but basically get into an environment that they didn't want to send additional people into unless they had to, and understand what's on the other side. If there were more people that they had to go in and rescue, what the status of those people in the building were. So that's sort of all the different areas. But again, it all comes down to sort of keeping people safer, keeping people out of a dangerous environment, and de-escalating situations in the end.
Yeah, no, it makes total sense. And I think, when we talk about multimodal robotics, that's going to be an important one, because I think you just outlined a scenario where, we've got some kind of overwatch or aerial vehicle that's going to identify, oh, this is a suspicious package on the ground. This is potentially dangerous. We're gonna either deploy manually or eventually autonomously deploy some kind of ground vehicle to go and check that out and possibly disarm it if you have a disruptor. But really to maintain safety. So Carter, so obviously the above ground stuff, we have the advantage that we can get eyes on it and visual. And I think when we talk about Homeland Security, suspicious packages, all that stuff, particularly for any kind of maritime vessel, but even cities like Toronto, for example, even Boston that are on the lake, where you could potentially have nefarious people planting devices underwater. And we've certainly had people interested in, underwater inspections of vessels and things like that. So talk to us a little bit about how Deep Trekker can help out with that same kind of a scenario that Matt talked about for above ground applications.
Yeah, absolutely. And it's funny that it's such a relevant topic is underwater security. It's such a big blind spot currently, and we have all these incredible tools for above the surface and gaining that situational awareness, which is so important for strategic decision making, that in a lot of situations just doesn't exist underwater unless you're using an ROV. And we've been working with many organizations, but one I'll highlight, which not a lot of people think of. Usually you go to underwater, you think of mines or some kind of explosive device. But one of the areas that's been a huge growing point of interest for us and our users has been port security from drug smuggling.
Mm.
We are working very closely with US Customs and Border Protection to survey the hulls of ships that are coming into seaports throughout the US. And traditionally, these hulls aren't frequently inspected unless they're tipped off and they're inspected using divers. US Customs Border Protection Puerto Rico is one example I'll name, who's been using our ROVs for a couple of years now, and their seizure rate has gone up in the hundreds of percents. For these vessels that are coming into port, they're splashing an ROV in a matter of seconds, completing a full 100% coverage inspection of that large 200 to 300 meter shipping vessel and seeing if there's any parasitic device attached to the exterior of that hull. That could be the bow thrusters, the sea chest, somewhere in the keel of the ship. And up until they were using Deep Trekker, it's not something they were inspecting unless they had a call or a tip off. By splashing the ROV, they're able to get that full coverage hull inspection in a matter of minutes and figure out if there's something that's coming from Dominican Republic into a seaport in the US, and a diver's going under there, removing that device that's been attached usually to the bow thruster or a similar area, and being sold into the US markets. It's amazing, this blind spot and how much seizure rates have gone up. We just have sold a ROV to every seaport in Canada for this same kind of inspection because it is currently one of the largest blind spots in port security at the moment. Now, outside of that, when it comes to suspicious packages or bomb threats, many of our customers, whether they're police or Department of Homeland Security, they're purchasing these ROVs through a port security grant from the Department of Homeland Security because light bulbs are starting to go off in places on what a blind spot under the waterline currently is for global operations. And I think it's an area that we're going to see a huge amount of change in the coming years.
Fantastic. So just I'll get to another round of questions here, but if there's any audience questions, please go ahead and put them in the chat box, or those of you who've been doing it this week, text me directly. That's fine. I have my thing open there. So either one, whichever makes you most comfortable, and we'll have a Q&A time at the end there. So let's kind of build on that. Like, the security aspect of that is really, really important. And it kind of ties into one of our themes for the whole week, which has been this idea of AI and autonomy. And so AI for advanced autonomy specifically, but then also AI for some kind of analysis on the ground. So let's focus on the autonomy part of that. So there's a couple of different things. Obviously, we have auto walk missions with Spot. and then we have like a drone in the box type of technology for the aerial one. So Jon, I'm gonna start with you. So for those kind of security applications, how excited are you about drone in the box to be able to kind of automate this? There's not an event based, it's just general coverage and general situational awareness. What kind of impact do you think that will have?
Well, I think drone in the box is a great concept. It's a great idea. To scale it has been a little bit more complicated because there's still some level of maintenance and checks and things you have to do to the physical box and make sure things are working the ways they're supposed to. So there still has to be some human to some degree that takes care of this part. But the idea and the concept is to be able to deploy this and hopefully maybe in some manner of observing what the camera sees, that there is AI that more so than just taking off and landing to a point is actually seeing something on the ground and interacting to it automatically. That's where I'd like to see the drone in the box evolution. It's because we're still doing a very hands-on approach. Even if you're flying from the box, which automates the takeoff, it automates the charging, it automates a place for it to sit and hold while it's going, but you still have, again, a very human intervention here going on to fly it or look for somebody observing. It'd be really neat to see, not even just in public safety, but somehow the sensor recognizes that there's a telephone line down and creates a spot. Go check that out. Moves on the lines or the transmission lines and sees another issue and can recognize that. Go check that out. That's where I hope the drone in the box involvement goes. We're getting there, but we just got to get these initial concepts figured out. Of even the regulatory side is that you're really not having somebody manage your fly. I want to come back to the dragonfish because in my earlier scenario, I did talk about a very manual process of flying an Inspire, for an example, up to a location and having a payload operator running, right? Well, the Dragonfish doesn't do that. I mean, everything is automated on the pilot side. You're still thinking like I have to think like I have to be a pilot, know that there's obstacles and where I'm flying, what I'm doing, but the aircraft is managing all flight by itself. It figures out how it needs to stay in the air. It figures out where it needs to move itself to find the object on the ground that you're looking at. I'm just a glorified payload operator with a couple of sticks just in case there's an emergency. Everything else is being managed by the aircraft. So we also have a drone in the box concept for the Dragonfish. It's a big box. It's probably the biggest box I've seen, Kevin, of a drone in the box. We do have that, and what that does is being able to take a dragonfish and land on the platform, come into the thing, change the batteries, and send it back out for the extended amount of time that the dragonfish can fly, the extended amount of distance it can fly. That really opens up for Border Patrol on long distance to fly from one nest, and we call it the nest at Autel, from one nest to the next nest to the next nest. And because of that amount of time in between the nests, you can respond to some degree on something that's happening on the ground. Again, we still have to, have a human do this, look at it and go, hey, that's a problem, tag it, there you go. But I'd like to see that next development of where that's going. And I didn't want to segue right into Matt, but I know that in the automated side, you have things that are listening to stuff and making decisions on, that is a bad noise. The spot is listening and going, that's bad, and that automatic, hey, something's going on here. Besides the visual side, there's a lot of that going on. So I'll just kind of pass it over to that. But I think that's what I'd like to see in the drone in the box is more interaction, what the camera sees and the aircraft or robot or ROV making decisions to go, I recognize that to be a problem and I'm going to do something about it.
Mm-hmm. Thanks, Jon. So Matt, coming into that, so one of the really more powerful features Spot has, certainly on the industrial side, which we'll hear more about this afternoon with the OPG case study, is the ability to do auto walk, and even with some of the stuff Levitas is doing with being able to avoid moving obstacles and doing a lot of on the ground change detection as well. So have you seen so far in public safety, are people applying or thinking about applying auto walk to exactly what we talked about, which is this kind of automated patrol type scenarios?
Yeah, I'd say a little bit, and I'd say a few things. So when we think about AI, we're often thinking about it as athletic intelligence, the robot knowing where to go, how to move its legs, or if someone were to try to sweep the leg of the robot, it's not completely out of commission. And a lot of that stuff we have really solved for. I think the other things that we're adding on, focused a lot on industrial, but could translate is the autonomy piece. And the part that you are mentioning, I think, is a train and repeat. So regular security rounds, walking a fence line in a logistics facility or on a flight line or something like that. And those are areas that we're seeing the robot use, sort of true autonomy, or having an acoustic sensor or a thermal sensor that alarms if something is out of spec. I think the other thing, specifically in the public safety space, that we'll continue to develop on is what I would refer to as supervised autonomy. So you're giving it sort of this high level command. I want you to go into this room and then back out, like get back out of the area, or supervised autonomy in the sense of go pick up this thing and drag it, but you're giving it the initial task, and then the robot is figuring out the rest. I think in a changing environment that public safety folks typically find themselves in, people are still going to be analyzing the situation. And I like what Jon is mentioning of, you hear something in the drone or the robot sort of goes to it or goes towards it. But in the end, people, I think, will still analyze and have that sort of human level understanding of the environment for a long time. And you do want people to be in the loop of these decisions, but making it so they have to worry a little bit less about how to get the robot there or where the robot needs to go, and they can worry more about making a determination of sort of what the next tactic should be in a scenario. That's a little bit about how we, or how I think about it. Does that make sense?
It does. It does indeed. Looks like we had a little video issue
No,
with Jon, so hopefully,
my
there we
lights.
go. So Carter, I've heard rumors that you guys are working on some underwater autonomy stuff. Is that something you can talk about, or am I letting secrets out of the bag here on live TV? Oh, you're muted, Connor or Carter. Sorry.
I'll talk about what I can talk about. There's a couple of things we'll keep under wraps, but we do have some exciting things coming out we're pretty proud of. And it very much echoes what Matt is talking about, is that kind of operational autonomy and further streamlining the operations we've already streamlined to make it even more of an effective tool. So I'll talk about what we can do today. And this isn't our standard ROV package, because sadly, underwater, we don't have the same tools that you guys have on the surface. We don't have access to GPS or radio waves. We have none of that. So we need to add a couple other devices to our ROV to give it its own situational awareness for it to navigate through that water column. And those are devices called USBL and DVL. All you need to know is it's giving it its positioning, and more importantly, it's actually giving its altitude off of that sea floor. Using that information, we're currently able to give the ROV some directional autonomy. So a common application for this is many of the teams are using a boat with a side scan sonar to locate anomalies on the seafloor. That side scan sonar doesn't always have the clarity to determine whether that target they're looking at is a log or it's the body they're looking for. So what we can do is we can take the coordinates of those anomalies and punch it into the ROV, and it will navigate to those anomalies on its own. Now, the idea behind that is, in many of these instances, we're in very low visibility water. And having the ROV navigate itself to these points with a high degree of accuracy is allowing that operator to focus on the sonar operation, which is so important in these environments, to get confirmation on what they're looking at, and then move on to that next target until they find the person they're looking for. we're looking at expanding this more in the future, and that's some of the gray area we'll leave out. But we are part of a couple cool projects as part of the Canadian Ocean Supercluster, OSC, where we're doing flyouts from autonomous surface vessels. So those are big autonomous boats that are going out primarily to wind farms currently and launching the ROV out from that surface vessel to do underwater monopile inspections. So that USV is going out inspecting the wind turbine. It's sometimes launching a drone to do aerial inspection of the turbine and launching our ROV to do underwater inspections of the turbine. But a lot of that technology we're developing as part of this specific project is going to have major implications in first responder operations in the near future. And the reason for that is one of the things we're looking into is a ROV in the box, as Jon was mentioning. So a underwater drone in the box, or the resident ROV, we're calling it. And this is going to be really important for areas where maybe boats are coming into port, that boat's docking up, and we can launch that ROV autonomously, control it manually if we so choose. But our dream, and don't get me wrong, we're miles away from this, but is to have the ROV get launched out, inspect that ship autonomously, develop a digital twin of that ship, and see if there's any changes from the last time that ship was scanned. That could be maintenance and just general condition, but more importantly, that could be something that shouldn't be there, like a parasitic device carrying drugs or contraband into the country. So that's kind of where we're seeing things moving in the future. And we're starting to build some of the framework for that now with the autonomy we're currently developing. It's in the early stages, but it's a free beta that comes on all of our ROVs because we're trying to develop that data and build the backbone for this to become much more intelligent years down the road.
That's really cool, by the way, to think of
Yeah.
doing a reoccurring database with digital twins on the bottom of boats. Who the heck would even think of that, Carter? I mean, that is cool as hell. I mean, just you know.
Thank you. Yeah, we're a bit away, but that's certainly the dream at the end of the day.
Yeah, at the end of the, 20 years ago, people said these things flying around and carrying stuff would be dumb, or wouldn't work, and here we are.
True enough. Yeah, and so I think, again, it dovetails nicely, right? This is what we're going to have. We're going to have multi-modes of aerial vehicles, ground vehicles, and ROVs that are working together to create, multi-dimensional data sets, digital twins of different objects, autonomously, semi-autonomously, manually. But all that data is going to be collected and come together. And so for us, that's why the multimodal approach to this is so important. And for those of you that were there on day one, also with companies like Tomahawk Robotics that are doing single control for multi-modes of robots. And then you can see that is going to make the training for this much easier, a lot of familiarity with the data collection. So anyway, so I'm gonna wrap this up here. We're getting close to time. We do have a few minutes for some questions. Those of you serial texters have already hit me up with a couple of things. Again, those of you that prefer more conventional, please pop it up in the chat box. So this is a question. First one is for you, Matt. For Spot, are there different arm options available? So are you experimenting with different grippers, with longer arms, different functionality? Is that something that's in the product roadmap?
Yeah, not necessarily different physical arms, because that arm, remember, is fully integrated to the robot itself. So it's, in a sense, two robots working as one. So as the arm goes to, if you go to drag something, it's both the arm and the robot working. So the actual physical arm, we don't have any, urgent plans to make a new version of the arm. We have seen some customers do some adaptation to the gripper, and we've also seen sort of printed holsters that can hold different tools. So maybe a holster on the back of the robot that holds a socket wrench or another type of tool like that, or a standoff Raman sensor that needs to be pointed towards an object to identify what it is. So I would say more gripper adjustments and gripper changes. And then it's just with the existing arm, adding additional autonomous capabilities on top of what's available today.
Interesting. And just as a side note, we actually had one of our minds that wanted to use Spot to do some core samples for post blast, and so we're calling it Project Sandcastle. So exactly that. It's going to be like a shovel attachment and a little sand bucket that's going to go on the back for analysis. So great to hear that. Next question is for you, Jon. So the question was from Mike. What do you see as the replacement of Dragonfish? Is it replacing or enhancing the use of public safety fixed wing aircraft so far? How do you see it?
Um, well, there's already been, I've been working with the Dragonfish, like I said, for nearly 2 years, and there's always the question of carrying capacity. So, what can you carry? Which basically means to me, what can you deliver? What can you drop off? What can you do? Something like that. And being that, yes, it can go a great distance, it can fly for an extreme amount of time in comparison to most drones. I think that would be something to consider in the next evolution is just how to, incorporate a cell phone drop for somebody or incorporating a way to land and not necessarily delivery like we're thinking like Walmart or UPS or something like that, but more or less the emergency level deliveries or carrying something, because it's a very, very common question of like where, what can I put on there, a different sensor, I want to be able to map with it and collect more data because it flies for so darn long, and so I think that would be some great suggestions on how take advantage of the way it's designed. One thing I really do, appreciate is that when people tell me, it actually flies really well in the wind. Well, that was what impressed me the first day. I've flown, we've flown lots of different VTOLs that just do not do, regardless of what they say, they do not do well in the wind. They don't do well managing how this has to track an item and stay on task and stay on its spot in the wind, landing in the wind. Then that's a really big challenge too. So flying from a maritime boat, these are already projects we're working on and doing. So that's another involvement is how to land with the big Dragonfish on the boat and trying to modify that to be able to do that. So there's a lot of cool things in the pipeline of ideas and then how to implement them as we get into the engineering side. We don't make thousands of these, you can end up making hundreds of thousands of these things, right? But we don't make a whole lot. So the development cycle of that does take a little time, but it's really exciting to kind of consider how others are asking what's the, what can we do? What more can we do? So,
Okay, couple more questions. So Carter, this question is from Anya for you. How much detail can you actually make out with your high quality sonar? Is it like close to LiDAR level data? What kind of accuracy levels are you getting?
So we have 15 different imaging sonars we use for very, very different applications. Sadly, there's no silver bullet when it comes to sonar technology. It's all a trade-off between frequency, and which is kind of like your resolution. The higher frequency you have, the better the picture. But high frequencies don't travel through water well, so then you become limited by range. So the sonar I typically use for, let's say, a body recovery application is going to be an Oculus M1200. So that's a 1.2 megahertz sonar. With that sonar, we can count the fingers on a hand in zero visibility from about 30 feet out, but we just don't have that same amount of range. Now we can get a much higher level detail sonar at 3+ megahertz. And we have some videos on our YouTube you can check out where we're literally inspecting pipelines and finding hairline cracks in concrete using a sonar in zero visibility conditions.
Wow.
But your maximum effective range on that system is like 9 feet, just because high frequencies don't go through the water. So it's a trade-off. And the question you got to ask is, what is the goal? What data am I trying to capture? And we'll work with you to find the best sonar system that's going to be best for you. Because at the top end and frequency, we can get amazing like millimeter precision, but you can't see far at all. So it's that trade-off.
Perfect. Couple questions from Michael in the chat there. So Jon, 2 questions. So first question, has your product been tested in the Arctic where we have super cold weather? And then second question is, what's the longest distance the Dragonfish can do?
well, I flew in Toronto with you in some crappy cold weather.
It's not quite Arctic cold.
No, it's not. But yeah, I was slushy coming down sideways while you're making me stand out there flying, Kevin. No, no, we have not, we have some temperature, top and bottom operational numbers that we work from, that the engineers say. Have I personally flown in really cold weather? Yes, to -10. And again, that's more than the threshold than the aircraft could do. But when you're talking about extreme cold all the time, there can be some factors there. So to answer the question, not necessarily in the Arctic have we flown, but I have flown in definitely inclement and cold weather. And whether it's sustainable, whether we have icing, all these other questions are definitely there and prevalent. If you're not already flying small multi-rotors up there, you can also still have the same issues. So, and then the second question of the distance. So the Dragonfish Standard flies 43-ish miles per hour if there's no headwind and no tailwind. If it can fly for an hour and a half to 2 hours, how far can that go? Pretty damn far. About 80 miles on a single in an hour. It can just one way, one direction, no return, is that it can do about 80 miles in an hour and a half to 2 hours. With that being said, most people are asking how far can it go to stay connected to it. So we do have a patch antenna that we released here called the ASAT. It's a tracking antenna that's good to track the dragonfish up to 100 miles or 60 kilometers. Is that right? There, my metric
No,
people.
100
60,
miles, 100 and it's about 130 kilometers.
there, but it's 100 miles.
160 kilometers, sorry.
Yeah, it's 100 miles. So you can, it's pretty far. And with that being said, will the aircraft go that far? Sustain that far, drive that far? Can it fly that far? Is usually the question. But you can always have a good fidelity of question, at least that distance out.
Okay, fantastic. Well, I think that's all we have time for. So, speakers, just stick around with us. We'll go into backstage mode in a second. But all our viewers, thank you very much for joining us. Jonathan will put our next session. So once again, just a reminder, 10 o'clock will be advanced industrial inspection. So a little bit of different group. And then, sorry, that was 2 o'clock. And then 3 o'clock, we will have an in-depth OPG case study. So for you, people that are really interested in spot and autonomy, please do join. Sorry, and that's 3:15. We'll actually have a little break between the two of them. So thank you everybody for tuning in, and we look forward to having you join us at the other sessions. Have a great day.